Hey guys, it's Mrs. McCune. Today I wanted to show you this simulation that goes over how balanced and unbalanced forces affect the motion of an object. So today we have this cart full of candy. This candy was collected Halloween night, last night, and we have two teams here that found this cart of candy and they're going to fight over it today, like a candy tug of war. So the very first thing I want to ask you guys is what combination of people would I have to put up here in order to have balanced forces on either side of this candy cart? Go ahead and pause the video and share your answers. All right, so you could have picked any number of things. You could have said one of these little guys on either side. You could have picked a combination of guys on either side. Notice that they don't have to be in the same location on either side in order for these forces to be balanced. You can see how the forces are balanced by looking at these arrows right above the candy cart. You can also choose different numbers of people. You could choose two little guys and one of these medium guys and still get a balanced force. But for the sake of symmetry, just making things kind of look equal, we're just going to use the same number and size of guys on either side to get a balanced force. Now, once we have this balanced force on either side, we're going to click this go button and these guys are going to start pulling. I want for you to make a prediction about what you think is going to happen to this cart of candy once these guys on both sides of the candy cart start pulling. Go ahead and pause the video and you can record or share your answers with Miss Campbell. All right, so here we go. Let's click it. I want for you to go ahead and cheer your team on. Who do you think is going to win? If you don't think anybody is going to win, then you can just sit there and cheer if you were right. All right, 3, 2, 1, go! All right, notice guys that nothing is happening here. Both of these guys are pulling on each side with equal force. So why is it that the candy cart is not moving? Go ahead and pause the video and you can record or share your answers with Miss Campbell. All right, if you said that the candy cart isn't moving anywhere because the forces are balanced, you are absolutely correct. Both sets of guys are pulling with equal force. The forces are balanced and therefore the cart is not going to move anywhere. All right, so we're going to reset this, and now I want to know what combination of guys we would use in order to have an unbalanced force on this candy cart. Go ahead, pause the video, and you can share your answers with Miss Campbell. All right, so I'm just going to pick any combination of guys here to have an unbalanced force. You can see here that the blue team only has one guy, giving him a smaller force arrow, and the red team has two guys, giving them a larger force arrow. If we click here on the values, we can see here that, you know, the little blue guys put a force of 50 newtons on, and each of these little red guys puts a force of 50 newtons on for a total of 100 newtons. Now, I want for you guys to predict what you think is going to happen to the cart of candy once I press go. Go ahead, pause the video, and share your answers with Miss Campbell. All right, here we go. Go ahead and cheer your team on if there's a team you think is going to win. And again, if you don't think that a team is going to win, then you can just cheer if you're correct in the end. All right, 3, 2, 1, pull! All right, so notice that our red team is currently winning this tug of war for the candy cart. Good job, red team. Go ahead and think about our answer here. Why do you think the red team was able to win in this tug of war? Pause the video, share your answers with Miss Campbell. All right, if you said it's because the forces were unbalanced, you are absolutely correct. The red guys had a stronger force than the blue team did, and that's why the red team was able to win. So what I want for you guys to notice here is that when we have balanced forces, the motion of the cart does not change. In the first situation, we had 2 blue guys on the left, 2 on the right, with a total of 100 newtons in both directions, giving it a net force of 0. This means that the cart is not going to move. In the second situation, we had 100 newtons of force pulling left from the blue team, and 50 newtons pulling left for the blue team, 100 pulling to the right for the red team. And that gives us a net force of 50 newtons to the right, meaning that this cart is going to move to the right. So unbalanced forces are what cause the motion of an object to change. If the forces are balanced, the motion does not change. That cart is going to keep doing whatever it was doing. If the forces are unbalanced, that is when the cart's motion is going to change. It will either speed up or slow down, or it could possibly change directions. All right, so what we're going to do is we're going to set up a new scenario. For this scenario, I'm going to start out with unbalanced forces, just like before. And then, actually, let's do it this way. You guys think a bit more. We're going to start out with unbalanced forces like this. And I want for you to predict what you think is going to happen. Once I start this simulation, the blue guys are going to pull to the left and the red guy is going to pull to the right. And as we know, the blue guys are going to start winning. They're going to start moving that cart to the left. And after the cart gets moving, and here's where I want for you to think about what's going to happen. After the cart starts moving to the left, I am then going to take this red guy and add him to the red team, giving the cart a balanced force. All right, so here's what's going to happen. All right, we're going to start. Blue guys are winning. Let's pause it. Okay. Since the blue guys are currently winning, I am then going to add this red guy to the red team here. What do you think is going to happen to the cart now that the forces are balanced? All right, go ahead, take a second to think about it, write your answers down, or you can share your answers with Miss Campbell. Okay. Let's see what's going to happen. We're going to start out with these blue guys pulling. All right, notice that the forces are unbalanced here. The blue team is winning, and here I go, adding another red guy so that the forces are balanced. All right, notice that nothing actually happened. Once those blue guys started to win, those red guys put an equal force on the other side of this cart, but the cart's motion did not actually change. Let's take another look at this, okay? So right now we have a net force of 50 newtons to the left, and we know that this means that the blue guys are going to start to win, right? When we put another red guy on, what we're actually doing is balancing out these forces, and the sum of the forces is still 0. Remember, balanced forces do not change the motion of an object. Once this cart started moving, a balanced force on the red guy's side would not change it. What would we have to do in order for these red guys to start winning? All right, go ahead and think about it for a second, and then Miss Campbell will call on you to share your answers. Pause the video if you need to. All right, so let's go ahead and start this one up again. This time what we're going to do is, in order to change the motion, we're going to have to make the forces unbalanced. Okay, remember, balanced forces do not change the motion of an object, only unbalanced forces do. So in order to create that unbalanced force, let's get it going. We got the blue team winning. Here's our balanced force. Nothing actually happens here because it's balanced. But in order to get the cart moving back to the red side, you have to unbalance this force. You can see that there's a net force of 100 newtons now to the right. Okay? So the key idea here, and this is very important, you guys need to understand this for your test, is that balanced forces do not change the motion of an object. We can see that here. The forces are balanced, 100 in either direction. The sum of the forces, or the net force, is 0, and you can see nothing happens. In order to change the motion, we have to have an unbalanced force. Balanced forces on moving objects do not change the object's motion either. In order to change the motion of a moving object, you have to have an unbalanced force, like now. See it slow down and start to move back to the other side. We can do the same thing again by unbalancing this force. We got 250 on the blue side, 350 on the red side. And if we balance these forces, nothing happens, okay? So balanced forces do not change the motion of an object. If the object is sitting still, it will continue to sit still. If the object is moving and the forces are balanced, it will continue to move. The only way to change the motion of an object is to use unbalanced forces. Thanks for joining me, guys. I hope you were able to learn something great here today. You're going to spend some time working on your study guide reviewing your net force worksheet. You can go ahead and take a minute, and I want you to review your answers and see if there are any answers you would like to change now that you have seen this video. All right, talk to you guys later. Have a great day.